This last video, we're going to continue to look at our sum and difference formulas, but with the intent of verifying identities. So previously, we've been working with, verifying all these identities. We've got our reciprocal, quotient, Pythagorean, even, odd. We also have these cofunction identities. You can see that I've listed one of these cofunction identities here. But we're often put in charge of actually saying, can you verify this? Can you show me that the left side actually does equal the right side? So that's going to be kind of our approach here, is that we want to show that the left side equals the right-hand side. But previously, how in the world would we have ever verified this identity? I certainly would pick a side to work on and work on the left side in this instance, but there are really no substitutions we could make outside of just explicitly using the cofunction identity. So if we didn't have a cofunction identity in our back pocket, we kind of wouldn't have any other ways of rewriting this. So now that we have sum and difference formulas available to us, we can actually expand this cofunction identity because it involves a cosine of a difference of two angles here in this particular instance. So, can we show in this case that cosine of pi halves minus x is equal to sine of x? Well, we actually can, because what we'll do is we'll kind of treat this how we do the cosine of a sum or a difference of any angles. If we had cosine of u, and I'll even write it as minus here because we're doing a difference, u minus v, we could always choose to rewrite this as the cosine of u, and then it doesn't alternate, so the cosine of v. Our sine would be opposite over here, and we get sine of u. Sine of u times the sine of v. So we're going to expand this on the left-hand side and kind of see where this gets us here. And so I'll kind of draw an arrow down here to say that we're just moving past this here. But we're going to use our cosine sum and difference formula. So in this case, our u is kind of like this pi halves here. Our v is kind of like this x. And we ignore, calling x negative. We say that that minus right here is only going to impact this middle sign over here. So looking at this, let's expand it. We have the cosine, cosine. Cosine doesn't alternate. And this middle sign will be a plus in this case. And then we have a sine sign. And then we'll go plug in our angles that we see are evident here. So we have pi halves is our u. So pi halves goes in front. Our x goes next. And then over here we have u and v as well. So pi halves and x. Just like we would normally treat this, like in our last video here, we can evaluate for the cosine and the sine at pi halves. We just really can't do that for the cosine of x or sine of x. So we'll leave those general. And so what we end up with in this next step, and I'm going to go ahead and just fill this out now, is this expression that looks like this. We're going to go evaluate, okay, for two of these that we can. Now, with respect to evaluating for this, I mean, you use your unit circle, but I suppose pi halves is kind of a neat angle because it terminates here. And so if that's our angle right there, terminating right there, remember that this is 0, 1 on the unit circle. So that means that our cosine value here, our x value, is 0, and our sine value here is the other part of this. This is 1. So some things we're going to be looking for. Remember, we were trying to show the left-hand side equals the right-hand side. And the right-hand side is like just sine. So what are we expecting to see down here? Well, one thing we hope to expect to see then is that this 0 times cosine kind of eliminates this cosine as being any part of this. And of course, 1 being the multiplicative identity, anything times 1 is itself. So we end up with this sign right here. And this is what's going to allow us to say, well then, hey, the sine of x is equal to the sine of x here. And we've actually showed that this identity is valid here. We just previously didn't have a way to expand this cosine of a difference of two angles here. So use your sum and difference formulas any chance you get to kind of try to rewrite things, see kind of where it takes you. And especially if you're verifying identities, it's always kind of a good habit to have. Cheers.